back to our discussion of Class 8 NCERT book, Chapter 8, Force and Pressure. Now we have covered everything on force up till last video. We will now move on to pressure. So what is pressure? How do you define pressure? Is pressure related to force in any manner? Yes, indeed. Pressure is force upon area. Area on, on which the force acts. In other words, pressure is defined as force acting on a unit area. Please remember that we will consider only those forces which are perpendicular to the surface. Like this. If we have the surface like this, the force acting on it are at 90° to the surface, making 90° with the surface. Or if the surface is vertical, then the force is acting at 90°. We are going to take this into consideration for a discussion on pressure here. Now we will discuss more about pressure through few examples. Why do potters place a round piece of cloth on their head while carrying heavy loads? As we know, the formula of pressure is force upon area. The area is in denominator. So, larger the area, smaller is the pressure on the surface for the same force. Thus, the cloth piece helps to increase the area of contact and thus it reduces pressure on the head, making it easier for the potter to carry very heavy loads. Our next example is, why is it easier to hammer a nail by its pointed end than its head? If we have the surface like this, we have our nail here with the pointed end and we have a nail here with its head at the surface. We have this hammer with us striking at the head in this case, and we have the hammer here striking at the pointed end. So what happens is that we have a surface here. In the first case, the nail is placed with its pointed end, and in the other case, we have the head placed on the surface. When we strike the hammer, a force is applied. Now the area of the pointed end is smaller than the area of the head, and we have the formula as pressure upon equals force upon area. So the smaller the area, larger is the pressure. So in the first case, that is the nail with the pointed end, the pressure is higher as compared to the second case, making it easier for the nail to be hammered into the surface. Next we have our example. In the same way, it is easier to cut fruits with sharp knife than with a blunt one, because a sharp knife has less area of contact than a blunt one, thus helping to apply larger pressure to cut the fruits. Likewise, the shoulder bags come with broad straps instead of thin ones in order to increase the area and reduce the pressure of bag on our shoulders. Next, we will discuss few properties of pressure. First is, pressure exerted by water at the bottom of the container depends upon the height of its column. To understand this in a better way, we will see a demonstration here. In the water bulging activity, what we do here is that take an open cylinder from both ends. We seal one end with a balloon and secure it with a rubber band. Now what we will do is fill the water in the beaker in the tube from the other end while holding it vertical. The balloon will bulge out due to the pressure of water. Now we are going to increase the amount of water in the tube. With increase in height or increase in quantity of water, The bulge in the balloon also increases, demonstrating our first property that pressure exerted by water at the bottom of the container depends upon the height of its column. The pressure increases with the height and decreases with height in the tube. Next property is liquids and gases also exert pressure depending upon the area. Let us understand this with the help of an example of leaking holes in water pipes. When there is a crack in the pipe supplying water, we can see fountain of water ejecting from the crack. Smaller the crack, that is lesser the area, larger is the pressure of water. And larger the crack, that is larger area, lesser is the pressure of water coming out. Next property is liquids and gases exert pressure on the walls of the container. For this, we will do a wall activity in which we will take a beaker with an opening on its side, insert one end of the tube into its side and cover the other end with a balloon and secure it with a rubber band. Fill in the water in the beaker. What do you observe? You start seeing a bulging protruding out in the balloon. As you go on increasing the quantity of water, the bulging of the balloon increases. Thus, this exhibits that liquids and gases exert pressure on the walls of the container as well. More the water, more the pressure, as we already discussed in our first property. Next, liquid exerts same pressure at the same depth. We will understand this by doing a fun activity here. You can take any plastic bottle filled with water, puncture the bottle with holes on its sides but at the same height from its base. This is a must condition that all the holes have to be at the same height from base for this activity. Keep the bottle in vertical position and you can see water oozing out of holes in streams that fall at the same distance from the bottle. The water falling at the same distance from bottle from different holes at the same depth successfully demonstrates that liquid exerts equal pressure at the same depth. Next, air exerts pressure in all directions. For this, take a balloon which has holes in it. Try inflating the balloon. Will you be able to do it? No, you won't be able to do it. Why? Because air exerts pressure in all directions. As you blow air in the balloon, the air escapes through the holes in the outer atmosphere. Another real life example of this is air escapes from punctured bicycle tube. You have to close the hole to fill the air into the tube. That's it for this part. If you feel this video was helpful to you in any way, please like, share, subscribe and comment. Thank you so much for watching.